Welcome back. So this is another example on how to solve a first order differential equation. So this is the differential equation we're going to solve. So it's cos x dy dx plus 2y sin x equals cos to the power 4x. If you want to just pause the video and try and work through it yourself, if you know how to do this already and you want to check your answer, or just keep on watching. So the first thing to notice is that we need to have it in this form. We need to have the form dy dx plus py equals q, where p is a function of x and q is a function of x. They could just be numerical values, but they're generally functions of x. And so far it's not, because you've got cosine x there. So the thing to do is divide by whatever dy dx has been multiplied by in this original equation. So divide everything by cosine x. That's the first step you want to do. So when we do that, we're going to get dy dx plus, and this will be 2y, that'll be tan x now, because sin x over cos x is tan x. And then that'll be cos cubed x. And now it's of this form, and we can proceed by finding the integrating factor. So remember, the integrating factor is the critical bit of solving a first order differential equation. Now the integrating factor is just going to be e to the integral of p dx. And p, remember, is a function of x, it's multiplied by y, and here we have 2 tan x, so y and then 2 tan x. So the integrating factor is e to the integral of 2 tan x dx. So we're just going to work out the integral of 2 tan x. The integral of tan x is the natural log of sec x. You either know that, or you look it up, or you just work through it. This video is not about working through that, by the way. This video is about trying to solve this. Okay, so if you're not sure about y, it's going to be e to the natural log of sec x multiplied by 2. You've got to look that up. Okay. Sorry, there was a line there, missing equals, not sure why. So we've got e to the 2 natural log sec x. Now when we've got exponentials and natural logs, it's convenient if you have e to the natural log something, isn't it? So we're just going to use that 2 there, and we're going to use the power rule and make that natural log of sec squared x. Okay? Then we can just say that e to the natural log will just cancel each other out, and you get sec squared x. So your integrating factor is just going to be sec squared x. Okay? Next step, you multiply both sides of this equation here by sec squared x. So you have that times sec squared x, that times sec squared x, that times sec squared x. Remembering that sec squared is 1 over cosine squared, so that will just simplify to cosine x. So here on the next page, you have this when you multiply by sec squared x, and as I said already, that will just simplify to cosine x. Okay? Next, in terms of what's happening, just a reminder of how this all works, you should end up with this result, that the derivative of the integrating factor multiplied by y will be the integrating factor times by q. The right hand side is obvious because this step we multiplied everything by sec squared x, so the right hand side is that. But the left hand side, curiously, you get integrating factor multiplied by y. Why is that? Just a quick reminder. If we write down d dx of the integrating factor, which was sec squared x multiplied by y, if you differentiate that, you will get this bit here. Using the product rule, remember the product rule is v du dx plus u dv dx. So if I say that is u and that is v, so v is y, du dx, differentiate sec squared x, you can get 2 sec x times sec x tan x, which is 2 sec squared x tan x. So that bit there, okay? So 2 sec squared x tan x is the derivative of sec squared x, and then multiplied by y. So this bit here is the v du dx. And then the other bit, u dv dx, so sec squared x multiplied by the derivative of y. Remember, you have to do it implicitly for when you're differentiating y. So sec squared x dy dx, that's that bit there. So I'm just demonstrating for you this critical result here. You don't have to do that in an examination, but it's just reminding you why this whole process works. So we've got this result here, and once we've got the derivative equals something, to undo the derivative, you integrate. So the integrating factor multiplied by y will be the integral of the right hand side, which is this result there. You can just write that down if you're memorizing this as a result. You want to do it as quickly as possible for examination purposes. Okay, so the integrating factor, sec squared x, multiplied by y, will give you the integral of the right hand side, cos x dx. And you just got to integrate cos x now. And of course, that's just going to be sin x plus c. So you get y sec squared x equals sin x plus c. If you want to write the solution with y as the subject, you can multiply both sides by cos squared x to get y equals cos squared x multiplied by all of that, which I've just written as sin x plus c in brackets. And that's just what we call the general solution. Remember, the general solution is when you leave the constant in it. For a particular solution, you might be given some boundary conditions at the beginning. For example, it might say in this equation here, the original equation, when x equals this value, y equals that value, you then substitute into your final answer and you get what's called a particular solution. Right, I'm hoping that you found that useful. Thank you very much for watching. Bye-bye.